This summer, the James Webb Space Telescope launched, marking one of the most ambitious NASA operations of the century. James Webb is intended not only to look back to the beginnings of space, but also to detect traces of life on exoplanets. Only since technical possibilities have improved enormously have we been able to detect planets outside our solar system at all. With James Webb, a telescope is now in use that can pursue the question of extraterrestrial beings like no other before it. One of the first mission targets in finding alien civilizations and traces of life will be the Alpha Centauri system. This is not only our closest cosmic neighbor, but also a mysterious signal reached us there not so long ago. Before we take a closer look at this phenomenon and other exciting details about unexplained signals from space, we would like to invite you to subscribe to our channel, activate the notification bell, and give us a thumbs up if you liked the video. We'll start right now with the details of the strange signal that came to us from the Alpha Centauri system. Signal from Proxima b. In December 2020, researchers from the Australian Breakthrough List project announced the observation of a striking radio signal. Something was transmitting a wave at the frequency of 982.002 MHz directly towards Earth. The Australian researchers were able to very quickly identify the Centauri system as the point of origin. Further investigation into the detailed source provided clues that the signal could have originated from the nearest and most Earth-like exoplanet, Proxima b. The excitement among scientists was great. Was someone from a distant civilization deliberately radioing a signal to Earth? Astronomers first had to verify that the signal was not coming from radio interference on Earth or from a natural source. Terrestrial interference could mislead telescopes, or natural cosmic events send unique, rhythmic, or highly conspicuous signals in our direction. Since Proxima b orbits its star in 11 days, the signal had to change within the 11 days according to the direction of the planet's motion. The signal was given the official designation BLC1 by the researchers. Shortly after the discovery, and even before the official confirmation, information leaked to the press. The British Guardian published a flash report about the signal from the Alpha Centauri system. Astrofans and scientists were beside themselves. Immediately, everyone wanted to know if BLC-1 was finally the long-awaited first contact with an extraterrestrial civilization. However, the observation of the orbital period of the planet did not bring the desired confirmation. Rather, it looked like the transmitter of the signal might not be on the surface of Proxima b. The values of the drift of the radio frequency did not match exactly. After the source could not be clearly determined, astronomers once again had no choice but to settle for conjecture and theories. Some believed that the signal, with a narrow bandwidth of 982.002 MHz, could very likely or definitely not come from a natural source. Others claimed that this was exactly the case, because a bright, long-lasting optical flare had occurred in the Proxima system 10 days before the striking signal was discovered, accompanied by a series of intense radio bursts. Radio bursts are events with very high and short frequencies and quite different from the signal BLC-1. Nevertheless, quite a few researchers assume that BLC-1 was a hitherto unknown accompaniment of the radio bursts. Until today, the origin of the signal could not be clarified clearly, and all hopes now lie with the new James Webb Telescope. This telescope will soon take a closer look at the Alpha Centauri system. The Alpha Centauri system. The Alpha Centauri system is a triple star system, and with a distance of about 4.37 light-years, our closest neighbor in space. The double star pair Alpha Centauri A and B is accompanied by an additional system. Occasionally, the star system is referred to as Alpha Centauri C, but much more common is the name Proxima Centauri. With the different name, astronomers want to point out that Proxima is part of the three-star system, but behaves completely different and probably has a completely different history of formation than Centauri A and B. The stars Centauri A and B are very likely about 5 billion years old and resemble our Sun a little bit, but Centauri B is much smaller than A. The third in the group, Proxima Centauri, is a red dwarf and has only 12% of the mass of our Sun. If the star had turned out a little smaller, it very likely would not have become a star, but a planet. In August 2016, researchers were able to prove the existence of several exoplanets in the Proxima system for the first time. One planet in particular caught the researchers' eye because it's located within the habitable zone of its star. This means that it's close enough to its central star to get enough light and heat, but also far enough away not to be turned into a blazing hot world by its star. Yet Proxima b is much closer to its star than we are to our Sun. The fact that Proxima b, with an orbit of only 11 days at its star, is nevertheless one of the potentially inhabited worlds is simply due to the fact that Proxima Centauri has only about 10% of the luminosity of our Sun. According to calculations, Proxima b is certainly a rocky planet where liquid water can be present. In addition, this exoplanet very probably has an atmosphere and is thus one of the Earth-like planets in space. At the moment, it's still very difficult for astronomers to find out exact details about exoplanets. Normally, these comparatively tiny celestial bodies can only be seen from Earth when they pass in front of their star. Then planets several thousand miles in diameter appear as tiny dots in front of glowing fireballs. What changes will James Webb bring? The James Webb Space Telescope is an exceptional project of NASA, the Canadian Space Agency, and the European Space Agency. Together, the participating nations invested more than $10 billion in the new telescope. The James Webb mission is ambitious. One of the most important elements is the 269-square-foot mirror, which consists of 18 hexagonal segments. This will allow the new telescope to capture light emitted just a few million years after the Big Bang. In addition to its mission to answer the big questions surrounding the Big Bang, James Webb was designed for another important mission, detecting and analyzing exoplanets. Like no other telescope before it, James Webb will be able to detect tiny planets over distances of thousands or millions of kilometers. But the telescope can do even more. Using the most sensitive measuring instruments and a variety of color filters, scientists will for the first time be able not only to detect exoplanets, but also to make them visible and analyze their immediate environment. Using colored light shifts and complementary ultrafine measurement techniques, James Webb can detect so-called biosignatures in space. Biosignatures include traces of water and organic elements. Similarly, technosignatures are not organic traces in space, but signals emanating from a technology. If the mysterious signal BLC-1 had been emitted by a radio wave transmitter of an alien civilization, this signal would be a technosignature. So in the coming months, we will learn for the first time whether Proxima b is really an Earth-like planet with traces of life. Furthermore, a close examination of the Centauri system could also finally clarify whether the BLC-1 signal was of natural or technosignature origin. In a study published in October 2021, it was said that between 2019 and 2020, about 15 signals were picked up that resembled BLC-1, but did not originate from the vicinity of Proxima Centauri. According to the researchers, this suggests that BLC-1 was not a technosignature or radio signal from aliens, and instead has another previously unknown source, or is human-caused electromagnetic interference, or in short, radio interference. The Australian researchers who discovered BLC-1 countered that the signal had been filtered and tested multiple times to rule out man-made interference. So it remains exciting, and ultimately we have to wait for the measurement results of the new telescope. James Webb will have a lot to do during his career, because BLC-1 was by far not the only suspicious signal from space. More mysterious signals from the cosmos. As part of the SETI project, scientists have been searching for clues about extraterrestrials in radio signals from space since 1960. In August 1977, astrophysicist Jerry R. Ehman, who was involved in SETI, received a narrowband radio signal from the constellation Sagittarius. Ehman scribbled, "Wow," next to his notes as an expression of his surprise, and promptly this observation was given the name WOW signal. At the beginning of this century, the signal named SHG B02 plus 14A was probably the most exciting discovery of the project. The astronomical radio source of unknown origin was discovered in March 2003 and announced in New Scientist magazine in September 1, 2004. The radio source was observed 3 times at a frequency of about 1,420 MHz and lasted for about a minute each time. The source is located in a region where very few stars occur, between the constellations of Pisces and Aries. Both signals are considered to be the most promising candidates for a real technosignature. However, this has not yet been confirmed. Unfortunately, we humans cannot simply send an answer signal in this direction. Also, radio signals are in space, years to centuries on their way. Signals from other worlds can take just as long to reach us. If we answer, there may be no one at the other end of the line, or the answer may not be understood as such. Nevertheless, people send signals into space, but with unknown receivers. Most of the time, these are codes that are supposed to be easy to decode and contain information about the Earth and the human species. The probes Voyager 1 and 2, as well as Pioneer 1 and 2, launched in the 1970s, also have messages for possible neighboring civilizations on board. The positions of Pioneer 10 and 11 are currently unknown because radio contact has been lost for years. Voyager 1 has been in interstellar space since 2012 and is expected to maintain radio contact with Earth until 2030. Voyager 2 passed the boundaries of our solar system in 2018. It will most likely take several thousand years for both probes to encounter neighboring stars due to their low flight speed. When and if we will make contact is still an exciting question, and we will of course stay tuned. We will keep you informed about the latest discoveries of the James Webb Project and other NASA missions. At the end of the video, we are of course interested in your personal opinion. Do you think the mysterious radio waves could be signals from extraterrestrials? Or do you think that the signals are rather of natural origin? We look forward to your contributions in the comments. See you next time at Simply Space.